Good morning. It's coffee time. I'm not allowed coffee or anything that isn't water right now, but hey, I'm here with you in spirit. So, mea culpa for yesterday. I was supposed to do daily space, and I have apparently discovered a new health problem. So, your 40s are wonderful, kids. And it basically knocked me out, and I couldn't wake up until the afternoon. So, I thought what would be nice is to show you kind of how I work behind the scenes, um, getting daily space ready. So that's what we're gonna do. So exciting! This is not planetary science news, so I got to admit I was a little nervous about kind of showing it anyway, but I'm gonna. So first things first, not what you see up here. First thing is that I go through my email and I dig out press releases. And we have this thing we use called Trello where we organize everything. And you can kind of see over here was Rocket Roundup, and over here is all of the stories that I sort of put in the list for Thursday. And then I take each of these stories, and in here you can kind of see gives me links. These come straight from my emails. And this is where we get all the stuff to put in the Patreon. So, here you can see there's a reference, tells me where the paper's at. I get all the links for it, everything like that. And then I go through and I open each of these. So the first story I was going to do is called Galactic Bar Paradox Resolved in Cosmic Dance. I have no idea what this means. There were two. So two different institutes sent press releases on the same story out. So I go through these and I look for what the good picture is. So this picture is nice and bright and shiny, and I like it. So this is from a simulation. It says the bar in the center and the spiral arms are thought to rotate at different speeds. If they are disconnected, the bar shows its true and smaller structure, which is the one over here on the left. Every time they meet, the bar appears longer and its rotation slower, and that's the one on the right. Yeah. Okay. I believe it. It's not a planet. Oh, hey guys, look, cat. You get a cat. Someone mark the kitty sighting. Hi. This is my life. They haven't had breakfast, so they are all over my room right now. There are 4 others in here they're all here. You get all the cats today. Hey baby girl, please don't play with my headset. Hi. Oh yes, make sure you show everybody your butthole. Yeah. There you go. Please don't lay on my mouse. Oh, we're doing that. Okay. That's a good thing I don't have to type. Yep. This is how my mornings go. Now y'all get to see it. Aren't you thrilled? They appreciate the backyard full of, oh, somebody has catnip in the backyard. Yeah, if you could see the wider stream, you could. Yeah, they're all over my room. Okay, so I have no idea what this story means. Basically, there's something, there's this paradox where they get disconnected from each other, and trying to figure out the bar size and the rotational speeds, so that we can understand how galaxies evolve. I did research on galaxy evolution. I was not into it. So, nah. So, it's cool. I like this cosmic dance. I love when they use terms like this. So here we go. This is a good description. So I probably would have included this in my script. So the bar and spiral arm approach each other. Their mutual attraction due to gravity makes the bar slow down and the spiral speed up. Once connected, the structures move as one and the bar appears much longer and slower than it actually is. As the dancers split apart, the bar speeds up while the spiral slows back down. So that's something kind of cool to contemplate. I'm sort of curious now. So then this other matching press release has a nice graphic on how that actually works. So here's the bar's rotational speed, and here's the spiral's rotational speed, and it shows you where they're disconnected and that every so often they connect up, which is kind of cool. So you can see that, they get connected. That's neat. All right. As the bar slows and spirals, about every 80 million years, the two structures merge and move together. So that's that dashed horizontal line right here. So they have this period of 80 million years. That's pretty neat. So, and this is done via simulations. So it's amazing what we're getting computers to do. All right. So that was going to be story number 1. Woo. And then there's this pretty picture, which my caption is entirely in Spanish, which I can read, but that doesn't really, I didn't even realize it. So this one is from an institute in Spain, obviously. It's in English for the rest of it, so that's very weird that was not. Okay. So this is Galaxy NGC 4565. And this story was going to talk about the evolution of spiral galaxies. So I would go through this story, and once again, first thing I do is look for pretty pictures, and then save it, put it in this pretty picture, and then kind of go through the story and figure out how to write this script. So we're challenging the assumption. So we have the disk of the spiral galaxy, and then we have the bulge, that central bright area. So you see this is the disk here kind of running through the picture, and then you have this bright central bulge of the galaxy. So this applies to spiral galaxies. So what they've done is they've said previous studies have traditionally assumed that the disk brightness increases exponentially all the way to the galactic center. That's one of the things actually that I was studying. So I can say that in what I did, yeah, that was true. But they're challenging this, which is always neat. Using a new technique to separate the bulge from the disk applied to 135 spiral galaxies, they found a lesser contribution of stars from the disk to the overall brightness of the central galaxy. So that's pretty cool. So they pulled them apart rather than looking at them as a whole, which I think is pretty neat. Again, it's galaxies and not planetary science, so it's not really my wheelhouse. But yeah, so what they're saying is that the relative amount contributed from disk and bulge stars to galaxy center is different than presented in substantial number of stories that assumed an exponential increase up to the center of the disk. So they're basically just like, we're going to take this center piece out and measure it, and they're saying that this contributes to the brightness, this not so much, which is interesting. So yeah, that would have been story number 2. So you're kind of getting daily space, but in a very, very sort of way today. Hey, Guido, what time is it there? After it's like what, afternoon there? This is the Needle Galaxy. Cool. Thank you, Keeper. I am appreciative. Wow. Who wants a cat? Ever see the kitty? Oh, hi. Say hi. Say hi. Oh, I know you are a precious, precious princess. Yes, you are. She's just hanging out in my arm because that's where she lives. Oh, are you gonna move or are you gonna? All right. Okay. So, third story is. Oh, yes, but no. Okay. So every so often I get a headline that I'm like, why? This one is one of those. NASA missions explore a TIE fighter active galaxy, because beyond that, it's look at the jets from this galaxy. Aren't they cool? They make a TIE fighter. And now I'm talking to a tail. Hi, tail. Do you care about a TIE fighter galaxy, tail? Yeah? Cool. All right. Well, I'm going to explain. So again, this is one where I had two images or two articles on the same story. So this is in the radio, I believe. No. Yeah. Multi-frequency composite. So you can see that what they're talking about is these radio jets coming out here from this central part of the galaxy. And this galaxy is even worse named. Can you guys even see me through my cat? Okay, so she's just kind of right there in the corner. Okay. This is TXS 0128 plus 554. I'll take an NGC anytime over that. Okay, so this is kind of cool. So for the slide, I put them side by side so you could kind of see them. So here, this is observed at 15.4 gigahertz. So this is done by the Very Long Baseline Array. And this one, oh, she's following the mouse. Oh, that's great. And the one on the right is the multi-frequency composite, which gives a little bit more information for me. This shows that the young jets are originating near the supermassive black hole. Like you can see in the two different, I tried to get them close to the same size, but then it was getting out of control. So I just sort of left it here. The jets in this image started about 80 years ago, stopped, and then resumed 10 years ago. So that's pretty cool. Yeah, you're all just getting Puck, huh? Thank you, Puck. Everybody wanted you here. All right. You're way more interesting than me anyway. Off you go. From the cat nebula. Judging assault. She is judging me for not feeding her, is what she's doing right now. Totally judging me for not feeding her. They're all judging me for not feeding them. Okay, so this story, this is really just an image release. So the NIRAO website makes that pointedly clear that this is an image release. There's not much exciting going on. If I were to look back at that Trello, there is a paper. So this is in the Astrophysical Journal, but they're just calling it an image release because there's not a ton of substance to this. So this is saying that they've got radio emitting jets from this galaxy that's about 500 million light years away. NASA, of course, uses their Fermi telescope to find it is a faint source of gamma rays. So then these guys take a closer look and they can see that these bright lobes on either side or jet activity. So this is pretty neat. So basically, the interesting thing is that it emits gamma rays too, which is why it kind of got attention. So it got observed for gamma rays first, and then they went back and they sort of imaged it. This is pretty cool. So if we were looking at it dead on, we were perfectly perpendicular to the way this is working, you would see these jets and you would see the clouds here, right? But because we're not looking at it perfectly, they've sort of figured out that we're at it at this angle. So you can really see this front jet, but you can't see that back one. And so they look bigger to one side. So we get that TIE fighter sort of configuration. And that's pretty neat. So then this shows you the changing appearance. There's all kinds of really cool stuff sometimes in the press releases. Not always. I had a press release I wanted to share that was about, I'm going to look at my email, which you guys won't see. But this press release was 50 new planets confirmed in machine learning first. And then let me show you that. I was all, ooh, machine learning, exoplanets. This is cool. Not a graphic to be found. Not one. Not an artist's impression, nothing. So you don't get that story. But this is kind of cool. So they, University of Warwick, which has been doing some really amazing astronomy stuff of late, have found 50 potential planets using this new algorithm that they've developed. So it's kind of neat because, for those of you who did Bennu and we're constantly asked the question of why don't we do this in machine learning, it's like, well, because we'd have to train the machine learning first and then we could have it do it. But Bennu was, as we all know, rocks upon rocks upon rocks upon boulders upon gravel. So it's kind of a pain. But sometimes you can actually use AI to train things. So in this case, they actually did it so that they could use the AI to kind of go through all of this data from all of these telescopes, so Kepler and TESS in particular, and then try and find which ones are real and which ones are fake. And since a lot of the Kepler stuff has been confirmed and we're getting confirmations on TESS, they can actually say like, okay, we know which ones are real and which ones are fake in the data. Not fake, but false positives. And so they have to sift out all of those false positives. So rather than having people do it, which can take time, you can try and train a machine to do it. And so they've been working on this algorithm, and they basically said that they've managed to confirm 50 more. Well, they found 50 potential more planets that need to be confirmed. So that was a really horrible grammar, and I'm sorry. So these 50 planets range from worlds as large as Neptune to smaller than Earth, which is pretty cool. Smaller than Earth, those are hard to find. So now they have to go back and use different methods to confirm these. It's just the way we do that. Never take a single sample when you can take 5. So they'll go back and look at figuring out whether or not these are actually planets. But that's pretty neat that now we can put targets up there. So these are saying they're validated Kepler planets. So I don't know why they keep saying potential planets in one place and then validated planets in another. See, this is, again, press releases. That's just frustrating. But yeah, there was no picture, so I'd have to go dig up a picture from the internet, and I can do that, but So that was going to be your stories. Those were the 3. So I don't know how cool any of you find them. Pamela finds these way cooler than I do, which is fine. We all have our areas of interest and expertise. Let's see. I would watch a cat stream that was occasionally interrupted by space science. That's my house, so I should set up more cameras for cats. F Bennu, yep. So many rocks. Chocolate Bennu treats. Validation does require more than one transit. It also requires, so you can have more than one transit. You can also have different methods. So you can look at it for the wobbles. You can look at it for the changes in brightness. Obviously, that's the transits. But you have, I think there's like 4 methods for finding exoplanets, and transits are great, but they can give you false positives, so they have to use other stuff. Oh, Keeper of Maps, 100 bits for cat cams. Okay. What, my ears aren't enough for you people? Oh, who wants color? Does anybody want color today? Let's see if they'll work. Yeah, we'll just go with blue. I've been told to look at something. One sec. Keeper has captured an image for me. Thank you, Keeper. Just Puck's eye staring at me. It's disturbing. In my house, the void looks back. Oh, and the best part, she sleeps. Little tiny black cat sleeps in the basket of dark laundry. It's definitely a warning. Be careful when you throw your clothes in there. Need a way to remotely control the color of the. Yeah, it doesn't like you can do on like Mary Amber's stream where you can control the color of her lights. Come on, there, green. Yeah. Lost a cat that way once. It was not a happy thing. Oh. Yeah, so there you go. There's the image that Gordon captured. Thank you, Keeper. Yeah, that should just be my profile picture. All right. Anybody have any questions on these stories? I will do my best to answer them for you. For what I can. Oh, cat sleeping in basket of laundry to be put in dryer. So I learned this rule from a friend of mine too, that before you ever turn on the dryer, you have to count cats. So I have a rule that I don't start the dryer until I've counted 5 cats and they're all, I've seen them all visually, and then I start the dryer. My husband lost a cat that way once too, and it is not good. Is your black cat as pushy about demanding affection as mine is? You saw her. She came up here, she climbed on me. Yes. And she's my shadow. So my friend calls her my familiar. She follows me everywhere. So she might not be cuddled with me, but she will be on a pillow near me. She will be in the same room, generally speaking. Okay, hold on. Cat at my feet. That's my tortie. She is also very demanding about food, and she will make no bones about the fact that it is time to feed her. So right now she's giving me, I keep getting side eye from her. If I make my way towards the kitchen, I will get yelled at. She will yell at my son to feed her lunch. She will yell at me for treats and for breakfast. She will yell at my friend downstairs who comes over to help with the cats because she has a treat jar as well. And so yeah, there is a lot of, actually, now that I think about it, what have I got? Oh, what's this? Want some of these? There you go. Want to do? Oh, geez. Now I've done it. And now you really need a cam. Oh my goodness. Go have treats. Jeez. No, you have some. You eat your treats there. Greedy guts. That's it. That's it. That's all you get. But Mom, don't stick your butt in the camera. There you go. You got treats. Oh man, they are everywhere. It's like sharks. I have been swarmed. I wish you could see this, but there's just like a bunch of them. That's where she's going. She's yeah. So yeah, that was no, you can't see them. Yeah, they're yeah, they're on the floor, and it's just a mess of them. And I think there might be a fight about to break out, so that might not have been the best idea. Oops. All right. Let's see. So those are. I wonder if there's anything interesting in my inbox today that I can share. I mean, look, more galaxy news. Hubble maps a giant halo around the Andromeda galaxy. It's like galaxies all the way down today. So this is kind of a cool image, but they usually give me a better image. Here we go. Okay. So in the center of this picture, you can see the Andromeda galaxy. And then they're showing that this is this map, this halo. And then you have these yellow, orangey spots are background quasars. So 43 quasar scientists used to probe Andromeda's gaseous halo. So they were used basically they used the light to look at this immense halo and see how the light was absorbed. And so now they're kind of trying to probe the material. That's pretty cool. And then here they show you how big this halo is. So this is a picture of Andromeda taken from dark skies, and this is how big that halo would be and kind of the way it diffuses out in reality. So it's 2.5 million light years away is the galaxy, and the halo, if it could be seen, would be 3 times the width of the Big Dipper, easily the biggest feature of the nighttime sky. So if we could see it, but of course can't, because that is ultraviolet light. So that's pretty neat. See, ultraviolet light is observed by Earth's atmosphere, which makes it impossible to do with ground-based telescopes. So they used a spectrograph to detect ionized gas from carbon, silicon, and oxygen. Well, that's pretty neat. So yeah, so there you go. Some more galaxy news today. Do they mention if the halo and the black hole's magnetic influence are similar size? Let me see. I don't know, since I just got this press release and I'm just looking at it with all of you. Layered structure, 2 main nested and distinct shells of gas. Inner shell extends about 500,000 light years. It's far more dynamic and complex. Outer shell is smoother and hotter. Differences likely result from the impact of supernova activity in the galaxy's disk, more affecting the inner halo. So that's kind of cool. See, I don't see anything about connecting it to the black hole yet. I think that's one of those, okay, we found the thing. Now let's see what the thing does. So that's probably something more. That's really cool. All right. So more galaxy news. All right. Are there any more questions? Anything? Anybody? Okay, so we've set up our raid for Alpha Wolf today. And this has been community coffee. And I wish I had some coffee because I am not awake, but I have to go get fasting blood work done. Welcome to my Friday. So I am allowed water. I will have my caffeine later. I'm not really affected by caffeine and I don't like coffee, but I will come home and drink like 3 sodas because that's how the world works. All right. I don't see any more questions. My alarm is going off to tell me that it's 8 o'clock. So I think I'm going to call it quits here. And you guys be nice to our Alpha Wolf and rating, and enjoy. Have a good Friday. Have a good weekend. We will be back with more Daily Space next week and community coffee, and live should return to normal because this retreat is over. So everybody have a wonderful day. Wash your hands, stay safe, wear a mask if you have to go out, don't go out. And if you are anywhere impacted by forest fires, please stay safe. Please stay safe. Love you all.